let's say we're using an online multiplayer game and we want to create a user table. I don't know about you, but I've created this user table 100 times. Now, this is just an example, simple user table where we have an ID, a username, a Boolean active column, and then create date, right? So this is the table that we would have, we've built a million times, right? And again, this is in a relational database, so this is how we would do it in a SQL system. So the problem is that we lose that data, right? So what do we know about this user? Right now, we know of course, we know what their ID is. We know their username. We know that whether or not they're active, and we know when they created it. But that's all we know about this user, right? But what we don't know about this user, right? Did they ever change their username, right? What did they change it to? How many times? When was it updated? What was it before? Have they ever been inactive? Who made the change, right? So this information, right? We don't know any of this in our relational database now, right? And what ends up happening is that for each of these different use cases, you start to come across this when you're building in relational databases, right? And I've had to try to capture this information, which is basically an audit log of who's done what. I've had to solve this problem a number of different times. And in Java, I've tried to be super elegant and create things like property editors that are going to capture changes in my entity so that I can persist those changes as JSON to be able to have here are the fields that changed and what it was and what it's going to, right? And it's a naive approach to be able to get towards event sourcing, right? And it's one of those things where I came into event sourcing and I saw it and it was like, oh my God, I didn't need to do any of that. I could have just been doing this the whole time. And then it's like, oh my God, I'm so dumb. Why didn't I see this, right? And it was a profound change at how I view application development, right? So let's talk about how we would do this. How do we solve for this problem in event sourcing? So state transition is the key here. And as you see, there's a series of events that'll happen for every single, and you got to think about that table in a different way, right? And so this right here is a stream. And let's say for each user, we have a stream that we're storing these events to. And a stream is just that. It's a way that we're going to capture data and all of the events that are grouped together by whatever that context is. And in this case, it would be a user. So that user would have an ID. And we would be capturing these events in that stream. So user signed up, right? This is our creation event. And this is going to hold details about what's happened, who that user is, all the details we care about for what they signed up. But then we have a bunch of different other actions that will happen, like the user has claimed a username. And another example is a CSR claimed a username, right? So here, all of a sudden, we've got one use case that has changed everything so that we're able to capture information that we didn't know before with our relational database. So we know the details about when a user signs up in their detail. So this we knew we could have done this with our relational database, right? And now we know the username that they claim. So now we've got a use case where we now know that they've claimed a username and they didn't have one before, right? We know that they're active. We also know that they called into a CSR to change their username, and then the CSR claimed another username, right? That's powerful, right? So now all of a sudden we know the context of what their new username is, but we also know what their old username was, right? So that's incredibly huge, right? That audit log right there changed everything.